Okay, we just got to this point from the last video I did was the pre-AP type questions. So these are AP questions. And let me just make sure, yeah, we got up to the 86. So I'll start with this one over here. Now, this comes from 1969. Again, the AP goes back some time, by the way. So if I were doing this derivative over here, yeah, I'd say d dx. And the natural log of e to the 2x is just simply 2x. What's that guy's derivative? 2. And the answer is 2. So the next one, this is from 1969. A little stranger saying that, sine of x equals e to the y, and they're going to say that x is between 0 and pi. Let's take a look. Implicit differentiation. So differentiate sine, you get cosine of x. Then it'd be dx dx equals, well, the derivative of e to the y is e to the y. The derivative of y is 1, and then dy dx. So let's write down dy dx. And what's it going to be? Cosine of x over e to the y. You should realize that e to the y is just simply sine x, though. Cosine x over sine x. Now I know why there's a restriction over here. And the restriction is due to the reason that if I were to rewrite it that way, dy dx would be equal to, well, cosine over sine is cotangent of x. All right? That answer is listed right over here. Again, the restriction between 0 and pi because the cotangent's defined between 0 and pi. All right, let's keep going. Let's do the next one. This is a, this one is a problem because it's, again, implicit differentiation from 1973. So what do you have here? Secant squared. I'll write this over here. xy times, I gotta use the product rule now, so I'm gonna say xy prime, and this can be plus y, and the derivative of x is 1. So I think I'm kind of ready to multiply this thing out, and you're gonna get x, let's see, secant squared, xy, y prime, plus secant squared, y secant squared, xy equals 1. Now let me keep going. It's going to be x secant squared. This is a multiple choice, by the way. Equals 1 minus y secant squared xy. You can divide both sides by the coefficient on y prime now. And you get this. 1 minus, let's see, y secant squared xy over x secant squared xy. All right, so I'm looking at this thing over here, and I'm not seeing that choice. So I'm assuming I made an error somewhere. And so what I'm going to do, like if this was multiple choice M, I would definitely just say I'd scratch this thing because I'm not seeing anything that looks like that. And yeah, I don't see anything that looks like that. So let's go that over again. Where'd I go wrong? Let's take a look at that. Secant squared xy, got that. And then it's going to be xy prime plus y, got that. And 1. Let me go back to that then. So I'll write that down again for you. And again, secant squared, x secant squared. Sorry about that. Maybe I shouldn't erase that so quickly. And this happens a lot of times on multiple choice exams. You write the thing down and say what just happened over there. But let's write it over again. A little better at this time. Secant, I'm sorry, y. Let me get my eraser out again. All right, and divide through, you get y prime. 1 minus y secant squared xy. And it's really time to rethink now. And what do you get over here? X secant squared xy. Well, one thing I'm going to do looking at it is I'm going to multiply top and bottom by the cosine squared of xy. So we get cosine squared xy minus y oops, my pen's acting up again. Again, I'm multiplying top bottom by cosine squared. And then you get x over here. Let's relook at it and see what we see over here. And when I see cosine squared, now I see it right over here. It's choice A. This happens sometimes. You write an answer down and say, couldn't possibly write, I didn't see it, but then I did see it. So the choice is going to be A. So choice A. Let's go to the next one. And again, looking at it, write this down, dy dx equals 2 cosine 3x times, oh, you have cosine sine, right? I'm sorry, minus sine. So minus sine 3x, and then times 3. And what do I notice over here? I notice there's an identity. And identity is right over here. And it's going to be minus the sine of 2 times 3x, which is 6x. And then it'll be a 3 over here. Let's take a look at the choices. And, oh, it's not multiple choice. And the choice over here, I do see it right over here. This is what I got over here. I think I would probably write this one down instead, by the way. But anyway, they're both equivalent. All right, they're both equivalent. All right, let's go to the next one. And the next one is multiple choice. It says, if f of x equals x, find f prime at 5. Well, let's write this down. F prime of x is 1, so f prime at 5 is also going to be 1. So the correct choice is C. All right, let's go to the next one. And this one is f of x. And I want f prime, so I'll put f prime down. And that's going to be tangent squared of x, tan x, times root of x, which is 1, minus the top, which is x, times secant squared. All right, they want f prime at pi over 4. It's a nice number. The tangent of pi over 4 is 1, and 1 squared is 1. This would be 1 times 1 minus pi over 4 times, well, the secant is really, looking at that, is going to be the square root of 2. And when you square that, you get 2. So what do you get there? You get 1 minus pi over 2. And that's the answer. All right, we got that. Let's do the next one. This is dy dx. Quotient rule, x squared, x times 1 over x, minus the top, which is the natural log of x, times the bottom's derivative, which is 1. And I think I got it. 1 minus the natural log of x over x squared. All right, we're good. Let's keep going. 93. 93 says the limit is what? All right, let's take a look at it. And I don't like the way it's written, by the way, but I'll rewrite it for you. And the reason for that, I don't like the way they wrote the tangent down. It's really tangent of 3 times x plus h minus the tangent of 3x. And this, it looks like a derivative, right? A derivative of what, though? So I'm going to say f of x looks like it's tangent of 3x. All right, that's what it looks like. So let's write down the definition of derivative, though. F prime of x, the limit, h goes to 0, right? And this could be h, and this will be the tangent. And that would be 3 times x plus h. I do see that. I'm just checking things out. Minus the tan of 3x. That's not so bad. So yeah, I'm agreeing that that's what f of x is. So what does this thing represent? Well, this thing represents over here the derivative. And what's the derivative going to be? Well, it's going to be secant squared, 3x. Derivative of the inside is 3. So it's going to be 3 secant squared, 3x. All right? Let's keep moving. And let's put this one down. This is, it doesn't look that bad. Let's put the derivative down, f prime. And that's going to be a product rule. Let's go through that. You don't have to do a product rule on it, but I like doing the product rule. So I'm going to say the first function, which is x minus 1 squared times the derivative of sine, which is cosine, plus, now it's going to be the derivative of the first function, which is 2, x minus 1 to the first power times 1, and then sine x. And it's going to be f prime at 0. And what do you get there? Well, put 0, you get minus 1 squared, which is 1. The cosine of 0 is 1, plus 2. Well, if I put 0, I get minus 1. And the sine of 0 is going to be 0. So what do you get over there? 1 times 1, which is 1. All right, let's keep moving. And it looks like an implicit differentiation problem. And they want to know what dy dx is when x equals minus 1. Well, you know, if x equals minus 1, I want to figure out y too. So let's put this down. So y equals minus y plus 1 plus 1. So you would get 2y is equal to 2, or y is equal to 1. So I'm going to put, if x is 1, y is also equal to 1. Now let's see if we can get the derivative now. And I'll write this down, dy dx equals, well, it's going to be the derivative of x, which is 1, y, plus, let's see, x times dy dx, that's the product rule, plus 2x, derivative of 1 is 0. So they want to know dy dx, write this over here, when x and y are 1. Let's see, plus 2. I made a mistake. I go back over it. And you might wonder why I made a mistake. I just look at this thing, it's just not possible what I'm doing over there. So again, you get over here, and I'm going to write this down again. And let's try, oh, it's minus 1, I'm sorry. So x is minus 1. So let's put this down. You're going to get y equals minus y plus, oh no, I didn't make a mistake before. 1 plus 1, that's 2. So you get 2y is equal to 2. Y is equal to 1. So yeah, x equals 1 and y equals minus 1. Let's do the derivative again of this thing over here. Y prime equals, I'm going to say y plus x, y prime plus 2x. Let's see if we can do that again. And what do you get? You get y prime. Again, y is 1. And x, I said, was 1 before. It's minus 1. So that's minus y prime minus 2. All right? So what do you get? 2y prime is equal to minus 1, or y prime is equal to minus 1/2. All right? So that's right over here. All right, we're good to go. Let's keep moving. And we'll go to problem number 96 now. And again, you know, I'm looking at the derivative. A lot of derivatives here, aren't there? F prime. Quotient rule. That's going to be 2x. That thing going to be in squared. 2x times the derivative of e to the 2x, which would be e to the 2x times 2, minus, let's see, the function e to the 2x times rid of the bottom, which is going to be 2. All right, let's clean it up a little bit. And the first thing I'm going to do is I'm going to factor out let me just multiply it out. 4x e to the 2x minus 2 e to the 2x over 4x squared. All right? I'm going to reduce it by dividing top and bottom by 2. You get 2x e to the 2x minus e to the 2x over 2x squared. I'm going to factor out e to the 2x. And what do you get there? You get 2x minus 1 over 2x squared. Okay? Again, if these are multiple choice, you'd be looking for those choices in the K. All right, let's put this one down, and they want to know the derivative. So I'm going to put down the derivative and see what happens. And that's going to be cosine e to the minus x, derivative of the inside, which is e to the minus x, times the derivative of minus x, which is minus 1. right, let's write this down. F prime of x is equal to minus cosine e to the minus x. Let's put this in the front too, e to the minus x over here. All right, so I think, yep, we're doing okay. Minus e to the minus x cosine e to the minus x. All right, we're getting close to the end. I hope we are anyway. F prime, and that's going to be secant squared of 2x times the derivative of 2x, which is 2. And we got to evaluate f prime at pi over 6. Kind of remind you of right triangles. When pi over 6 is a 30-degree triangle. Looks like this over here. So that's going to be 2. This will be root 3. That'll be 1. All right? So if you think about it, it's what's cosine of 2x? I'm sorry about that. So I got to do 60 degrees. I'm going to erase this now. Pi over 6 is 30, by the way, but it's twice x. So what happens, I'm really looking at this triangle over here, 60 degrees. That's going to be root 3. That'll be 1 and a 2. All right? So the secant of, if I did the pi over 6 and pi over 3, which is 60 degrees, that would be 2. All right? 2 over 1. And the square of that's 4. And 4 times 2 is 8. All right? All right, let's keep moving. This one doesn't look too bad, so I'll write this down. So f prime, it's 1 over the argument, which is x plus 4 e to the minus 3x times root of the inside, which is 1. The root of 4 is 0, and then I get minus 3 e to the minus 3x. They want me to evaluate this thing at 0. Let's plug that in. You get 1, and you get, I made a slight mistake over here. It's a plus sign there. So it's going to be 4, and e to the 0 is going to be 1. And then what do you have here? You get 1 minus 3. Let's write this down. You get minus 2 over 5. All right, let's keep going. And this one over here says, let f be a function defined by blah, 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 and g be the inverse of f, and g of 2 is 1. Okay? So I'm going to say that I'm looking at this thing over here. I want to point out, I'm still going to do a table. And I'm going to do a table with the understanding that really g of x is f inverse. So I'm going to put x and f inverse over here. Again, f inverse is just g. Now what do I know? 2 gives you 1. Now someone says, why do you do that? Because now I know what x and f of x is, the table. It's going to be 1, 2. All right? So what do I have to do? I don't know. I got to do g prime of 2, right? So what are we going to do over here? Let's take a look. I think we've done this before, right? And I'll write this one down for you. G of x. There's many ways to do it, by the way. Equals f inverse of x. And what I'm going to do over here is I'm going to plug in f of x. I'm going to plug in f of x over here. All right? So what do you get? You get g f of x equals, well, f inverse of f of x is just x. Let's start differentiating now. So g prime f of x times f prime f of x is equal to 1. That's not so bad. Now, so what do they want to do? They want g prime of 2. All right? So I'll write this down for you. The f of x is equal to 2. I want that. All right? So someone says, do you know the value for that? I do. It's f of 1 is equal to 2. So what's x going to be equal to? X will be equal to 1. So let's write this down. So g prime f of 1, I'll do it to all the work, times f prime of 1 is equal to 1. Now, what's f of 1? F of 1 is 2. So g prime of 2 equals 1 over f prime of 1. So I don't know what f prime of 1 is, by the way, but I do know f. It's over here. So I'll write this down. F prime of x is 3x squared plus 1. And f prime of 1 is going to be 3 plus 1, which is 4. All right, so what do you get over here? You're going to get 1/4. It's a multiple choice exam. I think it is anyway. And do I see that? It's choice B. All right, so the answer is 1/4. all right? So that was 100, and I think that covers it out. We're done, all right? Now, granted, I think a lot of these questions, you might be confused by them, but the bottom line is he really does have a nice worksheet here. It's from 2009, and this guy here, I'm saying, has a lot of good resources on the web, and this is just one of those. Thank you for paying attention.